All right. Happy Tuesday, everyone, and welcome back to another Learning Tech Talks where we are, you know what, today we are back on the track of exploring the landscape of learning technology while cutting through the fluff. Today's conversation is about the metaverse, one of the most misunderstood terms in the tech space right now, I think. And to navigate this conversation with me, I'm joined by Rajesh Jha, and he's with SimInsights, which, if you saw from the headline, is a no-code metaverse solution. So we're going to talk a little bit about what that means and how it's making what many have thought to be a unreachable capability quite reachable. But Raj, thanks for joining me today.
It's great to be here, Chris. Thank you.
Well, so to kick things off, and you know what, I got to say, it's going to be a good conversation when I'm having another conversation with somebody that has a map behind them. We both have maps. I think we're in good company with that. Although yours is a little more globally focused than mine, so I'll give you that. But where are you right now? For those who are joining, where are you located?
I'm located in Irvine, California.
Okay. All right. So Irvine, is that? I'm trying to think. Where is that abouts in California? Is that by LA?
It's about an hour south of LA and about an hour. It's between LA and San Diego, right by the beach.
Okay. Oh yeah. So you're the part of California that people think of when they think, oh, that's like a great part of California because it's like sunny and things like that. I had somebody on who was from the Bay Area, and you talk to folks in the San Francisco Bay Area. It's not always sunny and nice and warm in the Bay Area, but in other parts of California it is. So, okay. And so let's talk a little bit about your background in this, because obviously you're leading a company that's focused on making immersive tech accessible, but at the same time, and we're going to get into this, not just for hard skills, not just for things like that. And this is going to be kind of a fun one. But where did that start? I mean, how did you end up getting into the space?
Yes. So I grew up in India in a small town called Patna. And my memory from being 8, 9, 10 years old is every Sunday I used to watch Star Trek with my friends on a black and white TV. And one of the things in that series was the holodeck, where you could simulate pretty much anything.
Oh, yeah. Okay.
And we used to talk about that all day, the rest of the day. And so as I grew up, I went into engineering, mechanical engineering. And after I finished my bachelor's, even in engineering school, undergrad, I was working on building a simulation engine.
Okay.
And I came to US. The plan was to go to.
I like how you talk about that so casually. I was working on a simulation. I mean, that's not the kind of thing I was working on in college. We'll just say that.
I was a little bit extreme in that sense. Nobody else in my class was.
Well, you had childhood visions of the holodeck, so I guess it's appropriate.
Yeah, I was really, when I first saw my first computer in college, I was blown away, and it has not stopped. So I came to US. The plan was to go to graduate school and become a professor. But after my master's, I thought I'll join the industry. So I joined a company in Detroit called Altair. It's a public company now, and I spent 10 years. It's one of the leaders in simulation technology, but the focus there is product design. So their customers are all the manufacturing companies: Boeing, GM, Toyota, Porsche, anybody you can think of who makes anything. And what I saw was the use of simulation at a massive scale for product design. You simulate physics on the computer, so you don't have to build prototypes in the real world, and you can get everything done 10 times faster.
So that company was doing simulations, but it was more for like the product design things. Let's replicate. Let's create a digital version of something so we can manipulate, modify, tweak, but play with the physics and see how this all is going to work, so we can determine before we actually take the time to manufacture this thing, how's this thing actually going to play out? Exactly. Okay.
And that industry has continued to grow. But after about 10 years, I kind of had, I started thinking, okay, I'm very comfortable, got promoted. Is this what I want to do for the next 20, 30, rest of my career? Okay. And I felt that I needed to challenge myself. So I started this company, SimInsights, and I put the word sim right in the beginning.
Okay.
The second part was the insights part was really about learning and training because
Okay.
uh, um, what changes in somebody's mind when they use a simulation. And I picked UCLA because they have a great school of education that does a lot of research in learning and assessment. So I
Yeah.
got my MBA there and worked on the company in parallel. Now this is 2009, 10. There are no VR devices, even mobile devices were very early. Um, so I had to kind of find ways to keep going until about 2016 when the
Okay.
VR AR devices came to the market. And that's,
Yeah, when they kind of hit their, I mean, they existed, but they weren't really anything anybody had accessibility to. It was, you know, yeah, they were very expensive, very hard to get access to.
yeah.
Okay.
Once in our team, we started playing with these devices, there was just,
It was game over.
there was just no turning back. And there was an opportunity to bring all those ideas to reality with a focus on learning and training.
Okay. So total random question, because more just curious. So initially you thought you were going to go into academia, kind of go the academic route. What ended up making you even divert? Because obviously you made a diversion from simulation design of kind of product design to more the education. But it almost sounds like there still was something connected to that education, because initially you were going to go traditional higher ed, then you went product, and then you kind of landed somewhere in the middle where it's like, well, I'm still doing education, but from an so why did you end up pivoting off of teaching in a traditional sense?
So after I joined my first job, within 6 months, I really was bored, as many of my friends predicted, and I applied for
Okay.
graduate school, had a fellowship to go to Penn, do a PhD in robotics and AI. But there was my company offered an opportunity to get a green card in just 8 months, so I shelved that plan. Then
Okay.
this,
I love the pragmatism of it. It was enough.
and then the 8 months became
Good
2 years.
reason.
And in those 2 years, I got promoted and sent to different countries, and I had this entirely new exposure that I never had before uh, in life, and that
Okay.
opened up new options. And I thought, starting a company down the road is not a bad idea. I can still have fun building new technologies and products, and mentor people, and work inside a team building cool things. So this is kind of how I talked myself out of that become a professor track to.
Got it. Okay. Okay. Well, but again, you kind of came back, like I said, you came back somewhere in between. So I am curious then on this piece, because you've obviously been doing this, and this is one of the things I think a lot of times people see this new space, or I'm not even going to say new space, immersive tech, VR, metaverse, as this new thing that kind of grew, in the past couple years, which it's grown, but it's not brand new. But I am curious how you've seen that change, because like you said, this was back in 08, 09 when you were first doing this, which I mean, not, and even today, not everybody has a headset, sitting on their desk, but in theory we could, because they're that accessible now. So I have to imagine in those early days, it was a lot of more conceptual prototype type work. I mean, how has that evolved relatively quickly in the last 10 years?
Yeah. So even in 06, 7, 8, at the company where I was working in Detroit, they had a room scale system called the CAVE. The CAVE, CAVE,
Cave.
is an acronym, as a computer aided virtual environment or something. But that's a very old technology, like
Okay.
90s, 2000s. You can find a lot of caves in different companies. So the way that works,
Really? So these were like a thing, kind of like, I mean, I just think you go back like to the 80s or something, like computers used to be full rooms in certain companies to be able to do this. So was it similar in those times where, like, if you were doing stuff with simulation and immersive, you had these giant kind of bulky environments that you had to work with?
so the way that cave system worked is you had lightweight glasses, but these
Okay.
had little balls, 2 or 3 balls on each of these glasses that were used for tracking exactly where you were looking. And there would be a computer workstation far off in the corner that would do all the rendering, and it would project it on the walls of the room. So
Okay.
it's coming directly inside your eyes, like today.
Okay. So instead of the screen actually being on your face, it was actually projecting it, but then the device was just more doing optical kind of tracking so that then it knew what to project on the walls.
Yeah. So virtual reality is very old. Even the first prototypes, I think, if you search online in the 60s.
Yeah, they go back.
Yeah. So because the value of having the display adapt to you was obvious to people long time ago, and it's just a matter of hardware.
Okay.
And interestingly, the breakthroughs that led to Oculus as a company happened right here in Irvine.
That's true. That's true. So as and we're going to get into how this all ties to learning and development, I promise. Because one of the things that, you kind of said, you obviously made this decision to say, all right, we need to go from simulating product design, which again, I think is another very powerful capability of simulation, to be able to say, well, rather than waste all the materials and the dollars on some of these things, like let's test this out and actually see how this plays out in real life before we invest the time, resources, and all this into actually creating this. The same is kind of true with learning and development, because it's like, well, why send people through all of the potentially dangerous or time-consuming, resource-intensive things if we can create a simulation, which is why I actually like the name of the company is more focused on sim instead of, XR realities or XR learning type of a thing. Because I do think sometimes the VR, AR, it's hard for people to kind of triangulate. So how does that then relate back to learning and development? So where did you get started with this? What were you simulating in the beginning?
So what I saw in the previous company was I would walk into a company like a Toyota or something, and I would teach them how to use the software system that I was helping the company build. And I would teach classes all day, all week. And I would, on the way back, tired, I would be reflecting on what did I do all week? And over, like so many countries. And what I realized is that I was back to teaching. So I wanted to first become a professor. Now
you wanted to go there, then you wanted to get out, and you realized you were doing the very thing you tried to get away from.
Yeah. And so I was doing that. And what were the students or the employees of the companies doing? They were learning. And what were they learning? They were learning how to use the simulation tool to understand how is the car driving? Why is this part braking? And so simulation has always been, from day one, decades and decades ago, it has always been about learning. It's like a fancy microscope that works not on optics, but physics. And you turn it into anything, and you can learn something about that, right? And it can be manufacturing processes, chips, or whatever, bridges, planes, cars. And where I grew up in India to being in the United States with all that the country has to offer, that is one of the most life-changing journeys I have made, right, from A to B. And so I thought, what enabled me to make this leap and so many people cannot make? It's just learning, right? So my interest in working on things that help people learn something is very deep. And so it just so happens that I worked in simulation industry for very long. So I just can't help trying to connect the two together and make it easier for people to learn better, right? And in our company, we believe that simulation content, 3D, immersive, interactive, intelligent content is the most powerful type of content because it's the closest to how the brain is, right? Like we are in a 3D world, it's interactive. And I think that if we can do a small part in making it easier for the instructional designers and L&D organizations to embrace simulation first in small ways and then gradually scale it up, that'll be a pretty exciting achievement, contribution from our side.
Well, and it's interesting you bring this up, and then I've got a zinger question for you that I'd love your take on. Is you talk about starting small and then scaling it up. And I think one of the things that I've seen, because I've been playing in this space for a while, and even simulation, because simulations, the other thing too for learning and development people is this isn't a new concept. We've been trying to do this since the dawn of time. I mean, we think about role play. I mean, that was a term we use more commonly in L&D. Like, what were you doing? Well, you were trying to simulate something, is essentially what you're trying to do. And so whenever we look at these opportunities for practice and application, it's like, that's what we're talking about, is where do you actually get the chance to practice and simulate what you're doing? But to your point, in some ways, I almost think the digital age, we've lost some of that in our field, because we've become so focused, and I don't think it's a bad thing. Well, I think the over-indexing is, but we become so focused on creating digital content for consumption that we've in some ways kind of lost our way in, well, right, but we used to, part of when we would design training was, well, we're going to teach you something, we're going to educate you, but then we're actually going to have you do something. We're going to actually make you do something with whatever that is to build the skill and get better at doing it. And I think in the digital age, we kind of moved to this, well, if we have new and different and cool ways of creating content, it only gets you so far. And I think that point of, we almost have to relearn that skill of, well, what is the actual application or the simulation that ties to whatever education we're doing? And you're not going to be able to do that for everything out of the gate. And I think that's what you're getting at.
Yeah. Yeah. So I think it was Einstein who said all models are wrong and some models are useful. So so the terminology is that when simulation is something that happens at runtime, and modeling is something that you do when you are creating. When you're creating a model of a car that you're going to use to evaluate how it rides, does it ride very rough or comfortable? You spend days trying to think about all the shock absorbers, stiffnesses, and geometries and tire types and stuff. And then you hit the button and let the computer crunch and you look at the result. That part is simulation. First part is modeling. So in modeling, the big word is fidelity. Like, there's always two things. There's the real world and the model, and there's always going to be a gap. And the shorter you want the gap to be, the more money and time you have to spend.
Yep.
So that's where the judgment comes in, the human judgment of, like you were saying, how much of that reality do I want to bring in? What's my budget? How much time do I want to spend? And that's the role of the learning designer and the L&D professional to.
Well, you kind of took the air out of the next zinger question I was going to ask, because in the post yesterday, kind of like teasing this episode, there was a pretty good discussion going back and forth with people on the concept, because sometimes I see this debate, and actually I'm posting about it tomorrow, kind of unrelated, but it's kind of this, well, virtual reality is not as good, or it's good or it's bad, it kind of drives me bonkers, because I'm like, that's not kind of your Einstein quote. It's like, well, it's not good or bad. It's just useful depending on what you're doing. So if I'm hearing you correctly, and maybe clarify, I don't think anybody I've talked to who's in this space is necessarily advocating that simulation replaces real life. Is that fair?
Yeah, it cannot really replace real life. Even if you look at the most expensive deployments of simulation, which are in flight simulator training, where you have a box on a steward platform and you are learning to be a pilot.
Yep.
It's very expensive, but after that, you still go on a plane and you fly.
You still go on a plane.
Yeah.
Well, and I think that's the point where I'm like, what we're talking about is, how do we close that gap from concept to reality so that it's not quite such a big divide? And I think that's...
If I can interrupt you.
Go for it.
That was exactly the tagline of the company where I worked, Altair. The shortest distance from concept to reality. I worked there almost 10 years.
Well, but I mean, that's really what we're talking about. And sometimes that's where I see the debate about immersive. And it's like, people are arguing over whether this is going to replace reality or not. And I'm like, I don't think you're understanding the purpose of this. The purpose is not to replace or eliminate the need to do things in real life. The purpose is to say, rather than saying, here's how I think this should work, now let's shove people into it and see what happens and go, whoa, wow, that was a big gap. Like we had a catastrophic failure. Okay, well, if we could have learned that in a simulated environment, we could have learned and made tweaks to the concept or the model so that by the time we actually get to real life, I mean, I'm just even thinking prototypes of cars. You don't want a car to explode with people in it. So you simulate it so you can practice the physics and the geometry and all this and kind of say, like, how's this thing work? So you'll catch if it blows up before you actually manufacture and puts this thing out on the road. And that's essentially what we're trying to do in learning and development.
Absolutely, 100%. And I'll add one thing. So what's happening now is that people are training robots in simulations.
Okay.
So you can
Interesting.
You can immerse. Okay, so self-driving cars, you know that they drive a certain amount of miles in the real world, and they drive 10 or 100 times the amount of miles in a simulated world.
Really?
So all these self-driving cars are learning to drive in a simulated world. Same thing for any robot. And this is also not a new idea. This idea, when I was applying to go to graduate school in 2001, this was one of the ideas that was the reason why I wanted to go into the field, because there was so much that was that remained to be done. But today, with the technology that NVIDIA provides, what's happening is that I'm a robot. I'm in a simulated world. I'm getting frames from a simulation. I can't tell if these frames are from a real camera or a simulated camera, and I'm learning all the deep neural networks and controls in this simulated world. And I'm going to be, the moment I master something, all these neural network weights can get transmitted to all the other cars or all the other robots. So the reason why I bring this up is that it's kind of, it doesn't make any sense that robots are using some kind of technology that humans are still debating about.
So I know this is a total geeky, techie topic, right? I mean, I fully recognize, for anybody who's watching or listening who's maybe not into tech or is only just kind of exploring, I know you may be like, wait, neural networks, robots, like AI, like I get we're getting a little deep in it, but your point is actually one, I don't think we always think about that. The fact that it's like, so these self-driving cars, they're not learning how to drive on the freeway, nor would you want them to. You would not want a self-driving car working out the kinks, flying down I-90, taking out semis. You'd be, and if anybody proposed that to you, you'd be like, that's ridiculous. That is a ridiculous idea. We should never do that. Yet, on the flip side, when we talk about people, we accept that as okay. We're like, well, you know, I know these, I know these people have like zero idea how to do this job, but we've hired them and we think they have the right, you know, they answered the questions well. So like, let's just put them on I-90 and see how much damage they do. And it's like, well, we don't have to do that anymore. We actually can say there is a way to actually create those simulated environments that, even similar to your robot analogy, they can practice more frequently than they could in real life, because you can actually create a situation that is repeatable multiple times over for them to actually learn and practice and simulate, not to replace them doing it in real life, but to augment that, to say you can get better and better and better and learn and gain the insights so that you do a better job in real life.
Yeah, absolutely.
Okay. See, I get really, I'm actually glad you went down that like kind of techie, nerdy path with the robots, because it is really funny. Because again, if you were to propose that and say, no, we don't want to do simulations on robot training, it's too time consuming. It's a little you would be thrown out of the room. I mean, they would literally throw you out of the room, but that's kind of the way we've accepted that for people, and we don't have to.
Right. We don't have to. The technology is so good that it can, you know, a robot can be fooled that it's in the real world when it's in a simulated world, right? So the same technology is available for training people students, workers.
Okay. So I want to get into some of the depth of this, but let's flip the coin on this because, like I said, and Eric, I appreciate your, yes, we're not marshmallow fluff, but cutting through the other fluff, because there is, in all areas, not just immersive tech, sometimes marketing gets the best of things, and there's concepts and things, and it can be positioned in a certain way that makes it seem as though this is the silver bullet of everything, and it's not. So I am curious, what are some of the at least watch outs or limitations where you would say, going back to it, it's about really assessing the situation and saying, really what we're trying to do is close the gap. And we still need people involved in that to determine, well, what is the acceptable level of gap, or where do we need to close that gap? We don't just blindly throw this at everything. Having done this for quite some time, where have you seen where you go, well, these are some considerations to make, or how to think about this? And well, I'm going to stop there because I do think it is fair to say, listen, this isn't something that you just blindly go run around and do for everything.
Right. So in a business context, if a company is considering the most optimal way to train a certain number of people on certain knowledge, skills, and abilities, then you have to consider VR in the context where you have other choices. You have mobile, web, in classroom training, many choices. And then there is VR. So with VR comes certain number of issues, right? Like the headset, you have to invest in the equipment, people, as opposed to a phone, which everyone has in their pocket all the time, right? So when you look at it holistically, there are some areas that may not make sense to do this year in VR.
Okay.
And I'm not the expert on, if I say that topic X is not good fit for VR, I need to have done a certain amount of work on absolutely being sure. So I can't say that.
Well, and I don't actually think it's good to say this topic is good for VR or bad for VR, because honestly, it's one of those like, well, there's so much nuance, you kind of need to explore the topic. But I think getting to your previous point, what you were saying is, what are some of those considerations to be like, well, here's things you need to take into consideration when you're considering a topic.
Right. So the second part of how to go about answering this question is actually, so I used to think a year and a half ago that if you asked me a question about 2 years ago, I would have said, it's clear that VR is useful when the task involves a lot of physical motion.
Okay.
I no longer believe that, because there are studies that have come out that show that even for simple things like memorizing something or learning a concept, like a math concept, VR is superior. Or actually, I don't think that's quite been shown, but VR has a lot of potential to be superior.
Okay.
So the set of things that one could say that, oh, VR is not necessary for that or doesn't give you any additional benefit, that set of things is shrinking.
Yeah. Well, it's funny you mentioned that, because I have a similar point of view where I'm like, when I hear, oh no, VR won't work for that, I'm like, there's a very growing smaller and smaller category of things that I would say it doesn't work. Now, you may still look at a situation and go, I don't know that it's right for this situation because of this circumstance or for this reason or this environment. Sure, yeah, you may still come to that conclusion, but to conclusively make a blanket statement of it doesn't work for this, I'm like, I would be very careful saying anything about, well, it won't work for that. And I think your point of, I think before, and I think a lot of people still have this idea, well, it's really good for very tactical, you're trying to get people to practice doing a thing, which it is really good for that. But that's a very small percentage of what it's good for.
Right. Yeah. So okay. I was speaking with a researcher in the field of embodied cognition recently, a professor from Berkeley. And what he said, it's very interesting. He said that if you go evolutionary on the evolutionary timeline, if you go way back when organisms evolved, first they just had muscles to move. They didn't have eyes or ears or anything. They just had muscles. Then the sensory system evolved to support the muscular system, the control part, right? The sensory system came after. And then when people got into math and science, they didn't grow another part of the brain, the math lobe or anything. They just used the previous sensory and muscular systems to do this higher level thinking, imagination, which is very, very interesting. When I heard that articulation, it made sense to me because I've been reading papers in that field for about 9 months now. And there's a lot of, there's a portion of cognitive science that really believes that human brain is doing a lot of simulations.
Okay.
And so if you believe in that, then any skill, even if it's solving a math equation, it is actually a multimodal simulation where you have to think kind of with your muscles and your senses and rotate things. That's the natural way for people to learn anything, not just like how to work in a factory, but even solve a math equation. And that's why the set of things is shrinking, and that VR can help with almost everything going forward as we accumulate research evidence.
Well, and I think, something you hit on there that we just, again, don't even necessarily always consider. We actually are asking people to simulate, even in very basic things like reflect. Like when we say, oh, reflection we say it all the time. We're like, reflection is a key part of learning. It's like, well, what do you think reflection is?
Right.
Simulation. We're asking them to reflect and think through and process with your brain. How would you do this? All we're looking at doing with this technology is saying, what if we could amp that up and say, well, now instead of just imagining in your head, what if we could actually have you play that out? Going back to your point of this multimodality of don't just think about it, do it. Actually do it and have that environmental situation help support that reflection.
Right.
Okay. So with this one, the other one though that I think I do want to spend a little time talking on, because I think, you brought up this point where even some of the more basic things, when you look at immersive tech, and I'm going to stick with the hardware stuff, because I do think when you actually get in, while I understand there's a need to say, hey, what if you could do VR without the headset and you could do it on a phone or a desktop? It works. I think you do lose some of its efficacy in the fact that it's like, well, you lose the immersive factor to some degree, which I know I've had VR people on the show before. Some people get really intense about it. And they're like, that's not VR. I'm like, I get what you're saying. But with that whole piece, even the focus that comes from being in a VR headset has to contribute in some ways to people's ability to actually store that memory and actually be able to simulate better. Even just the sheer fact that it's like, I'm taking away distractions of other things. Is that part of what you're also trying to do by replicating that environment?
Yeah, I've heard that view many times, especially from teachers who work with distracted students all the time, and they love the idea of taking away all the peripheral distractions and focus people on a task, because that is definitely, and all of us can relate to that from our experience. That when we were focused was when we learned some concept, and we were just kind of listening to distractions. We didn't. There's one study that comes to mind that did the comparison, same thing on PC and VR, and they found that VR outcomes for recall were much higher, significantly higher in VR. So, and then there's another study that came out of MIT, which also found a similar effect. And what they wrote in the explanation why is that when you move your head to look at information, that has something to do with how that information gets encoded and how it's recalled, because you are engaging. And there's somebody else shared with me that there are studies that show that the more of your senses are involved in that experience, the longer you're going to retain it. I haven't read that paper myself, but I think it's all of the above. It's the focus, it's the multimodality, multisensory, sensory motor,
Yeah.
all of these things are coming together.
Well, and again, I think to your point, it makes sense, right? That the more active,
Right.
the more active you are in the learning, whatever that activity is, the more likely it is to stick, the more likely it is to actually transfer over because you're actually actively engaged versus if you're passively kind of have something in the background while you're half, I mean,
Right.
the people, we've seen all the things about can you actually multitask or not? No, actually, your brain's just switching super fast in between activities. So the more you can reduce those switching back and forth and engage other parts, it works better. But I think so here's this one, because just even from your website, you talk about this a little bit. I have been in conversations with folks about the whole, well, isn't this just for hard skills? For hard skills, technical or manufacturing, safety, things like that. And there's growing conversations about its use in soft skills or power skills, human skills, things like that. Share with me a little bit about how that journey is evolving, because I will say back in early days of VR, that was an area that I was like, it's not necessarily the greatest in that area because it is very tactical in nature. That, in my opinion, is changing significantly.
Yeah. So I've seen a number of claims by other companies that soft skills training in VR has delivered the outcome in terms of people feeling more confident and so on. There is some work that we ourselves have done with a healthcare company where we use conversational AI. The experience was ready to be delivered in Oculus Quest, but the client couldn't buy so many Quests, so we ended up delivering it on the through the browser. So it's not truly a VR in a strict sense.
But this is this like responsive design where it's like, well, it's designed to be done in a headset, can be, but if not, you can also deliver it through a browser.
Right. So in soft skills training, most of the high-end training, you do find that you can speak to the characters because that makes it more authentic. And going back to the multi-sensory, multimodal, the more senses you bring in, the higher likelihood that you will activate that in real life and transfer it, right? So I think that there are some issues that people can get hung up on, such as the uncanny valley of the characters not being photorealistic and lifelike, or the text-to-speech voices being robotic. I think that some people can be skeptical about that, and that's okay. Like, we just have to accumulate enough research evidence and data to show that there's outcome possible even with
right, that the outcomes outweigh the like quirkiness.
Yeah. I haven't seen any studies which really that's another thing. So yesterday I was in a webinar, engineering webinar, where it was about 3D printing, and there was a slide that said technology is ahead of the science. And I really liked it. And as an engineer, there have been so many occasions where, back in grad school, we could prove a theorem. And then when I went into industry, there are so many examples where the software just works, but there's no theorem proven that says that it should work. It's like, it's hundreds of times.
No, I agree. And I think that's one of the things with the pace of technology that has made it very difficult, is that it's one of these things where it's accelerated so fast. And I think immersive tech is one of them, where it's like, we have accelerated to the point where we can replicate things and allow people to practice and do things faster than the science could ever catch up to. Well, I mean, in terms of exactly how effective is this, or where do you use it, where do you not, like, it just it hasn't been able to keep up, nor probably will it, with the pace at which it's changing.
Yeah. It's very expensive to do proper scientific studies that you can submit in an academic journal. It takes a long time. Just the IRB process can bog you down for months. And we are doing some of those studies actually with some of our partners. So I know from experience. But to your question about what do I think about soft skills and power skills, I really think that VR has a lot to offer. And if we do these randomized controlled trials, we'll find that there is definitely ROI. And and there's definitely going to be advantage over other when you balance cancel out the other things like
Yeah.
yeah.
Well, and I think this just goes back to, it's not a good or bad or greater than or worse than. You have to evaluate the situation, say, what are we really trying to do? And do the benefits outweigh the risks or the limitations? Now, one thing I do want to define, just for folks who this may be, they may not be quite as nerdy as we are in these topics. We talked about conversational AI. How do you define what? I mean, it sounds pretty straightforward, conversational AI, but how would you define that? Like if you were to define it from a technical standpoint?
So the goal of conversational AI is to someday down the road have a virtual agent that can have a conversation with me or you the same way you and I are having a conversation.
Okay.
No.
And which is a combination of, it's a combination of NLP, machine learning. I mean, you got a whole lot of tech that's going into that. It's not something that is super simple, which I will say in this one. And to me, this is where conversational AI, as far as I'm concerned, is one of the most promising things for soft and power skill development in immersive tech, because this then actually allows you to simulate human interaction, which so often is the part we struggle with trying to simulate. I mean, and not just even without immersive tech, we struggle simulating that with traditional tech, where you're like, well, geez, do we have like the manager have this conversation? Do we put them in peer groups? How do we actually do this? And I think that's something that is opening up a wealth of possibilities.
Yeah. So at a high level, if you think about last decade, until 2020 was about computer vision.
Yeah, it was all about the vision.
For the most part, it's kind of solved. That's why you are seeing companies claiming they have self-driving cars, because now the cars can see. And similarly in robotics and so on. This decade is about conversational AI.
It's funny you say that, and it'll be really interesting to see how that progresses, because that does seem to have been the trend. It was like, well, we've got to get, and actually you're seeing some of these things in other areas, which you actually watch the subtleties in your consumer grade stuff. You see that it's starting to happen. Over the last decade, it was all about, and I even see, the CAPTCHA things where it's like, click the number of stoplights. It was all about training machines to visually recognize things and get really good at identifying the visual side of things, which we've come a long way now. And I've had a few of these voice captures and these things that it's trying to do, because it's trying to better naturalize human language and interaction and how that kind of stuff happens, which I got to say, for anybody who's trying to understand, like, how would you even, evaluate or go look at Otter AI or something like that. That's just a basic, it joins your Zoom meeting and transcribes your meeting and sends you meeting highlights. Like, this is just an example of the foundation of what's happening in the language space, which I think is going to be fascinating to watch over the next 10 years.
Yeah, totally.
Okay. So let's talk a little bit about how this actually works from an L&D standpoint, because I don't want to, miss that piece, because part of what you're doing is making this accessible, which that has been historically a limitation for folks, because maybe you're an L&D team and you went, we don't have Unity designers, or we don't have access to these VR environments where we can go create this stuff, nor do we even have the skills or the appetite to try and build those skills. So what really are you doing to try and make that more accessible so an L&D department can get into this space without all of that?
Yeah, so 3 years ago, we started working with the early customer, and they had a soft skill scenario that they needed to roll out kind of on an urgent basis. This was just before COVID. And so we talked to them, hey, what do you have? So they had flowcharts of narratives, and they wanted to train a few thousand people on how to handle those conversations with real life people who are coming into their establishment on a daily basis. So imagine the challenge of training a few thousand people on how to have a certain structured conversation, what to say, what not to say. in a way that you can sleep at night knowing that they will follow that training. It's a pretty daunting task.
Yeah.
And so uh, um, what we realized is that if we are going to build a system that's easy to use, we got to keep the interface simple as a flowchart, because flowcharts, nobody has trouble understanding flowcharts for dialogue-based scenarios, right? Even if you implement those, So that's what we have.
It's kind of an XYZ, like decision happens, this happens, you just kind of go through it.
So so we have created an interface like that where you lay out your conversation. And now how typically each conversational AI system has 3 modules at least. One, as you were saying, the transcribe module, that's called automated speech recognition, or ASR. So ASR will take the sound waves and convert it into text. Then that text goes into the second module, which is called the natural language understanding module. So that's where the NLP kind of processing happens, which makes sense of what is Chris really asking.
It takes it from just terms and words to actually what is being said.
Right, some intent. And then the third piece is that intent then gets handled, and some response comes out. And the third piece is text to speech, which converts some kind of text into sound waves that you hear. So in our interface, we enable the authors to go and lay out the conversation, select the voices for the characters, male voice, female voice, British accent, Indian accent, whatever, and that's it. And take all the heavy lifting of conversational AI and NLP away from them, and enable them to capture the scenarios that they are thinking about, and then deploy it and get the data back. That's very important, because even though the systems are very accurate today, they are far from perfect. So there will be some error, like if the author intended this, now the system is understanding it as something different. But we bring all the data back so that as you roll it out to batches of people, your system accuracy is going up and up and up, and your scenario is getting more and more powerful, more and more general. It's confusing things less. And so we have gone through that process with multiple customers and baked all of that into the product.
So with that, because I'm kind of curious about this, because this is one of the things that I do think ties to some of the skill sets. Because again, kind of understanding the flow chart of, we're kind of breaking down a soft skills situation where you're like, we want to simulate a conversation. Something's about to happen. From a design standpoint, there's a fair amount of effort that goes into, we need to first isolate what is this situation. Because I'm guessing when you're talking about some of these situations, this isn't like, we're going to simulate your 8-hour day type of a thing. We're talking about like, what is a situation that we know repeatably happens that we want to simulate, correct?
Yes, absolutely.
Okay, so part of it is actually getting down to what is the actual, again, if you're thinking in terms of learning and development, maybe we've done some, educational type stuff and we're saying, here's what we've taught you, but here's the situation we want you to apply it to. You need to get somewhat guarded in what that is so that it doesn't go off the rails. But then you actually even have to, from what I'm understanding, take it a step further. You kind of need to deconstruct that conversation and almost kind of anticipate, how predictive do you need to get in terms of how will this conversation go? So when you're talking about the flow chart, how granular do you have to get in breaking that down?
So the aspect that's important from an experiential point of view is that, again, the practice. What you want to do is, and they give your employees an opportunity to practice and get feedback, right? Now, so to that end, you want to have a clear idea of what is the situation you want to put your employees into. It's an easy example is let's say a receptionist, I'm manning the receptionist desk. People are coming all day long. And how do I treat them? How do I handle their questions, right? So if this was the goal, you can see you've narrowed it down quite a bit, and you can send different types of virtual humans, and they can throw different kinds of questions at me, and you can score me on how I'm doing, give me feedback. And after a little bit of that, I feel like, okay, I'm ready. And the conversational scenarios are on a spectrum from easy to very difficult. Like a sales situation is very difficult. because you have to control the conversation and take it to all sorts of places. And answering questions is not that hard, right? And things fall somewhere.
Yeah, if it's basic questions, we're just trying to get you, hey, I pose you with this question. Did you answer it correctly or incorrectly? That's going to be very different than we're going to have, like you said, a sales conversation. By the end of this, you should have convinced me to accomplish X, Y, Z. How that conversation goes, we may not necessarily, I mean, it's going to have to be a little more fluid.
Yeah. And that can also be done. It just takes more effort, meaning that you can spend more time anticipating all these branches. And so the software gives the tools to the content creator. And then the important thing is to also keep in mind that data has an important role to play, because NLP systems are not perfect. Even if you take a very capable human, they also will require you to give them exposure to a number of instances of a certain situation, right? If they don't have prior experience. So the same thing with the AI system.
Okay. So part of that simulation design is not just to be like, hey, we have this one very robotic, simple situation that you're going to go through. You're going to, I mean, the user is going to get bored if it's like Cindy keeps walking up to me and asking me the same question, and I just keep answering Cindy's question, and I'm told good, not good. And it's just this. So you are almost building a variety of these different situations that people can interact with.
Yeah. And we make all that easy. That's the hard work that we are doing every day, and taking feedback is how do we free the customers from the burden of all this technical complexity around conversational AI, and enable them to roll out scenarios that outperform traditional multiple choice type, or save the cost of in-person training, right? So that's kind of our focus.
So would you say, because I'm just trying to think of kind of where this is going from an industry standpoint, because if you look at, okay, and this is a similar path that followed with off-the-shelf digital learning. But I think the thing that's beautiful about immersive tech and AI is the fact that there's really no off-the-shelf, because there's no predict. It's like, well, that conversation is going to go how that conversation goes. But what, in some ways, what you're talking about, if I'm replaying this back correctly, is you looked at, let's use compliance as an example. You know, every company in the world had some instructional designer somewhere back in the day that would create their own version of ethics and compliance training. And they would try and create like, well, and here's the situation. They would come up with like, present you with these, how would you respond to this situation? How would you, and everybody was designing their own. And then eventually companies kind of caught on that, you know what, is what we're doing really that unique, or are these situations relatively similar? And some companies got wise to it and started saying, we can create ethics training for you that everybody can use, and it's 89, 90% of what you need. Is that kind of where you see immersive going, where it's like, well, it's not off the shelf, but we can know what the common situations you already are probably dealing with a relative sense of accuracy. You have the flexibility to kind of build some of your own custom if you need to, but we've also got a bit of a portfolio of ones that are relatively accurate. And because it's AI and NLU underneath it, people are interacting naturally. So it's not a, wow, that's a caged, kind of response type of a thing. Is that kind of the direction you see this going?
Yeah, it is very likely to go in that direction. And the way the AI techniques work is that is in line with the business model going in that direction, because you can take a little bit of data from a customer and fine tune the AI, make it even more specific to that customer. You don't have to start over. So it makes sense for one or a few companies to build up a big collection, just like it happened in the 2D kind of video or multiple choice.
Yeah.
The same thing probably will happen in this story.
Well, and I think that's an opportunity, when I look at because this was one of the barriers to VR for a long time. It was very expensive. It was very time intensive. And the shelf life, a lot of times, wasn't super long, because like the hardware would be out of date, or the technology would change so much, you kind of lost it. And so I do think there was good reason why in our industry we kind of held on getting too immersed in it, because it was like, well, I don't, we can't do this. But now that companies kind of in the middle can say, well, we can build and scale all of this stuff. We almost can kind of leapfrog what we did with digital content and not go through that awkward tween phase where it's like, well, we can kind of build our own custom VR if we need to. It's not going to be really that great. It's going to be behind. It's going to cost way too much, and almost just skip to things like what you're trying to do, which is, well, we can kind of get some partially prefab stuff to help make this happen faster.
Right.
Okay. Last question for you, and then we'll wrap up because we're running out of time here. What are some of the things that, if you look at what's changed in the last, since you started, right? So, since you really got into that, I mean, you've been in the simulation space for quite a while, but if you look at kind of where it is now, what do you think some of the biggest changes we're going to see in the next few years are going to look like? Like, where do you really see things shaping up or dramatically changing or dramatically improving over the next few years?
It's very exciting to think about that. You have headsets getting better, price performance wise. Big companies are investing huge amounts of money.
Okay.
Then you have 5G internet coming faster and faster. That's important because number of polygons matters. AI latency matters in conversation. Every 50 milliseconds speed up, you're going to notice it. So
that's because that's what we're talking about, where when you talk to this conversational AI and then there's this awkward pause where it's processing everything that happens and then it responds. And so the tighter we can get the internet speed, the faster that response is going to happen.
Yeah.
Okay.
So 5G is important. Headsets are important. AI is important, obviously. And then the graphics and rendering, the work that NVIDIA and others are doing in making everything photorealistic, that's important. So that's what's exciting for people in my generation who kind of watched Star Trek growing up. It's like, oh my gosh, that all stuff is closer than we ever thought back then.
Yeah. Did you think as a kid when you were watching this on your black and white TV, did you ever think that, like, no, this is something that legitimately in my lifetime, I'm actually going to get to play around with?
I can't remember what I thought, to be very honest, but as I grew and went into engineering, I'm always, among my friends and peers, I'm the impatient one. I'm like, why?
Welcome to the club. Okay. Got it. Well, you know what? I know this was, we got a little more technical than I have in some of the previous episodes, but I think that was actually extremely helpful because understanding what this is and how it all fits together actually does, from my perspective, make it feel less intimidating, less kind of ethereal, and more practical in terms of, yeah, this is super like, we don't want to undersell. This is super complicated, advanced technology, but it's much more accessible and it's becoming much easier to use to the common user than I think it ever has been.
Yeah. And there are a lot of companies like us making that happen, working hard every day. So for the L&D organizations, I really think that the time is now to start working with this.
I agree. And it's not always a popular opinion, but I will get behind it because, again, I feel like the person who like, if somebody suggested let's train robots without simulations, I'm like, that's essentially what we're doing with people, and we don't have to, and we just need to stop saying, well, that's just the cost of doing business. Like, it doesn't have to be. So I appreciate you taking the time today, Raj. Thanks everybody for tuning in. Hopefully you feel a little more. I made a post last week about raising the bar in terms of digital acumen and how we do this. Here was an opportunity to actually get a little bit deeper and raise your skills in those areas. So thanks for making the time, Raj.
Thank you so much. It's great speaking with you, Chris.
All right. Have a good one, everybody, and have a great week.